Hello everyone. Welcome to this exciting live video series on data science by Simplilearn. We are going to have daily live sessions this week that will cover all the important skills to help you master data science in a week. We are going to learn the leading data science skills and technologies each day with our highly experienced instructors. We will focus on programming with Python and R, data visualization, SQL, machine learning and more. So without any further delay, let's begin with day 1 of our data science week. So in this session, we are going to learn Python programming and understand the mathematical concepts required for data science jobs. Python is the most popular programming language for data science and machine learning and provides a collection of libraries such as NumPy, Pandas, Matplotlib, scikit-learn, etc. to analyze data and build prediction models. You will learn all the basics and advanced concepts of Python programming such as loops, functions, object-oriented programming, etc. Mathematics is equally essential for creating efficient models. You need to learn statistics, probability, calculus, and linear algebra to understand the working of machine learning algorithms. So let's dive deep and learn Python from scratch.
Let's begin and learn about the development of Python and gain insights about the current IT trends. Python is very famous for its simple programming syntax, code readability, and English-like commands that make coding a lot easier and efficient. Due to this, it is the most popular and preferred language. Python is an interpreted, high-level general-purpose programming language developed by Guido van Rossum at National Research Institute for Mathematics and Computer Science, Netherlands. In contrast to popular belief that Python was named after the snake, Python was actually named after the show Monty Python's Flying Circus. Guido van Rossum formulated Python in the late 1980s as a successor to the ABC language. In 1994, Python version 1.0 was released with features like exception handling, lambda, map, filter, and reduce. Python 2.0, released in 2000, introduced features like list comprehensions and a garbage collection system capable of collecting reference cycles. Python 3.0 was released on the 3rd of December 2008. Undoubtedly, Python 2.x and 3.x have proven to be the most used versions. As of today, Python 3.7.4 is the latest stable version released in the summer of 2019. Python is popularly used for development, scripting, and software testing. Top IT companies like Google, Facebook, Instagram, Spotify, and Netflix, among others, use Python. Some major applications of Python can be seen in the fields of machine learning, artificial intelligence, data science, and IoT. Python also offers many libraries like NumPy, SciPy, Keras, TensorFlow, Django, and Flask. Pep 8 is the official style guide that defines the styling conventions for Python code. A few popular open source Python projects include pipenv, Chatistics, solving the traveling salesman problem using self-organizing maps, and Python to BPF converter. Some of the trending Python repositories on GitHub today include NLP, ML from scratch, PyTorch transformers, 100 days of ML code, among others. Popular websites on the internet like Reddit and Quora are built using Python. Civilization 4, Battlefield 2, Sims 4, and World of Tanks are some popular games developed using Python. According to Indeed, the average salary of a Python developer in India is about 5 lakhs per annum, and that in the US is around $124,000 US. Users and admirers of Python, especially those considered knowledgeable, are referred to as Pythonists, Pythonistas, and Pythoneers. Since its inception, Python has come a long way to become the most popular coding language and continues to revolutionize the IT industry.
So what really is Python programming language? Python is an object-oriented, high-level programming language that supports built-in data structures and dynamic semantics. It supports multiple programming paradigms such as structured, object-oriented, and functional programming. Python is often described as batteries-included language because it has a comprehensive collection of standard libraries. Python supports different modules and packages, which allows program modularity and code reuse. Python was developed by Guido van Rossum, and its implementation started in December 1989. Python 1.0 version was released in the year 1994. Python 2.0 came out in October 2000, while Python 3.0 was released in December 2008. Now that you have got an understanding of the Python programming language, let's now look at the top 10 reasons why you should learn Python. So at number 10, we have ease of use. One of the most common reasons to like Python is that it is quite easy to learn and code. It provides a simple syntax that improves readability and makes it easier to understand. So developers can create any desktop or machine-based application using this language. Python is very versatile and is instrumental in artificial intelligence and machine learning. We will talk about this later in the session. Compared to Java or C++, it has fewer lines of codes. In the example here, we are printing a hello world program in Java. As you can see, if you have to write a program in Java, you first have to declare the class name along with its scope. Next, using curly braces, you need to pass the main method along with its arguments. And then, using system.out.println method, you can print hello world. That's quite a tedious task, isn't it? The same task of printing hello world can be done using just one line of code in Python, as shown here. You can write the print function and pass whatever you want to display inside the brackets, and that will print the output. It is so simple. That is why Python is considered as a high-level language and it's open source. You can just download it from the website and start using it. At 9, we have active community. You need a community to learn new technology, and friends are your best asset when it comes to learning a programming language. Python has large community support. It has an extensive and active community to assist engineers, developers, analysts, and data scientists with expert support in case of programming errors or issues with the software. You can just go ahead and put your queries in the community forum. The community members will address your queries in real quick time. Communities like Stack Overflow also brings many Python experts together to help learners. Python Enhancement Proposals, or PEP, is where the proposals and the improvements are announced. Also, there are a set of recommendations or core values called the Zen of Python, written by Tim Peters, that represents the guiding principles for Python development. Up next at 8, we have portable and extensible. Multiple cross-language operations can be performed effectively because Python is portable and extensible in nature. For example, if the users have a Python code written on Windows and they want to execute on a Mac operating system or Linux operating system or Solaris, they can easily do it without any amendment. They can also run this code on any platform flawlessly and without any interrupt. Due to its extensibility feature, you can integrate other programming languages such as Java, .NET, C and C++ codes with Python. The components of other programming languages can be used with Python, and thus it can be used to make a cross-platform suitable application too. So it is a really good feature that Python provides. The next reason to learn Python is testing frameworks. Python supports several built-in flawless testing tools and frameworks that help in debugging and speeding up workflows. Some of the tools and frameworks supported by Python are PyTest, Selenium, and Splinter. This is the reason for which every tester tries to use Python-based tools and frameworks to test any application or code or to validate it in an easier manner. PyTest is the most recommended testing framework for functional, integrational, and unit testing. You can run Selenium test scripts using Python programming language to automate various tasks. And Splinter is an open source tool for testing web applications using Python. It lets you automate browser actions such as visiting URLs and interacting with their items. At number 6, we have libraries and packages. Another reason why Python has become so popular in the industry these days is that it has a massive collection of libraries and packages that make your task simple and easy. It has a range of libraries, packages, frameworks, and modules for data manipulation, statistical calculation, web development, learning, and data science. Python programmers have developed tons of open source libraries that you can use. You can find many of them via Pythonx. The repository provides the default package. Anaconda is a third-party Python ecosystem. Other examples include NumPy, SciPy, and Django. Then we have scripting and automation. Python is not just a programming language. It can also be used for writing scripts for automating tasks and workflows without human intervention. The code can be written in the form of scripts and executed later. First, it is interpreted by the machine and checked for errors at runtime. The machine is used to read and interpret the code. Once the developer checks the code, it can further run or be used several times without any interruption. This allows you to automate a set of certain tasks within a program, or the same code can be used with other applications as well. At number 4, we have web development. Another reason to learn Python is that it makes the web development process so much easier. It provides a wide collection of frameworks that make it easier for developers to develop web applications. Some of the examples are Django, Flask, Pyramid, TurboGears, CherryPy, etc. These frameworks are written in Python, which makes the code a lot faster and stable. The task which used to take hours in PHP can be finished in minutes using Python. Python is also used for web scraping. Django offers many elements of intricate programs such as template design, management panel, signing in, signing up, signing out, URL routing, etc. Once the user establishes the framework, all these features become ready to use. Flask is a microwave framework written in Python. Of all the components that are part of this module, they are all ready to execute in the server context. Pinterest and LinkedIn use Flask. Pyramid offers more attributes than Flask. It will assist users with URL routing and authentication support. TurboGears is a highly recommended and scalable framework that supports features such as authentication, caching, identification, management of sessions, and pluggable applications. Up next at number 3, we have machine learning. The growth of machine learning has been phenomenal in the last 5 years, and it's rapidly changing the world around us. Python is one of the most preferred programming languages for machine learning because of its simple syntax and support for several machine learning libraries. Using different libraries and functions in Python, the system can learn and train itself from past data. Once the system is trained, it can then learn to adjust itself to new inputs. Finally, it can make predictions and perform human-like tasks automatically. At number 2, we have data science. Machine learning and data science go hand in hand. Python is robust, scalable, and provides extensible visualization and graphics options. Hence, it is widely used in data science. Python has libraries such as NumPy for numerical computation of data, Pandas for operations to manipulate data on numerical tables and time series. It also provides SymPy for symbolic computation and SciPy for technical and scientific computations. It has another library called PyBrain, which is sought for Python-based reinforcement learning, artificial intelligence, and neural network library. Scikit-learn is a machine learning library for creating classification, regression, and clustering algorithms. And finally, it provides PyTorch and TensorFlow for deep learning. Finally, coming to the most important and the top reason to learn Python, which is career opportunities and salary. Python language provides a variety of job opportunities and promises a high growth graph with huge salary prospects. It is being used by most of the tech giants. Industry leaders using Python are Amazon, Google, Facebook, IBM, NASA, Netflix, and YouTube. Next, you can see the Google Trends, where I have considered 3 programming languages: Python, Java, and C++. I have compared them for the past 12 months. You can see it clearly on your screens that Python has become a frontrunner in terms of popularity and web search volume. It means people are interested in Python, they want to learn it and use it in their work. You can also check for the YouTube search. There also you will find that Python programming language is the most searched language on YouTube. Now on your screens, you can see the report of PYPL, which is Popularity of Programming Language Index. It is created by analyzing how often language tutorials are searched on Google. It is a leading indicator. The raw data comes from Google Trends. The bar graph depicts that Python is the most popular and widely used programming language across the globe, followed by Java, then JavaScript and C#. The Popularity of Programming Language Index can help you decide which language to study or which one to use in a new software project. The next graph shows the popularity of Python and Java over the years, starting from 2004 till the current period, which is 2020. Worldwide, Python is the most popular language. Python grew the most in the last 5 years by 19.4%, and Java lost the most by -7.2%. Now let's talk about the different career opportunities and the job roles that you can get into if you learn Python language. First, you can become a Python developer, where you will be asked to write and test codes, debug programs, and integrate applications with third-party web services. Second, you can become a web developer. Here, you will be responsible for writing server-side web application logic. Python web developers usually develop backend components, connect the application with third-party services, and support the front-end developers by integrating their work with the Python application. You can also become a data analyst if you know Python. As a data analyst, you have to gather data from multiple sources using scripts, analyze that data, develop and implement databases, and data collection systems. You can become a data scientist. As a data scientist, you need to understand the challenges in business and come up with the best solutions using modern tools and techniques to analyze, visualize, and build prediction models to make business decisions. Lastly, you can be a machine learning engineer, where you can develop intelligent machines that can learn from vast volumes of data and apply knowledge without human intervention. So there's a lot of scopes if you learn Python. Now let's have a look at the salaries of some of these job roles. So if you become a Python developer, you can earn an average salary of $76,526 per annum in the United States, while in India, you can earn an average of 4,98,000 rupees per annum. Also, if you learn Python and become a data scientist, you can expect an average salary of $113,000 per year in the United States, while in India, you can earn an average of 10,28,000 rupees per annum. Let me now go ahead and call out the 10 reasons for learning Python once again. At number 10, we had ease of use. At number 9, we had active community. At 8, we had the portable and extensible feature of Python. At number 7, we saw the testing frameworks. At 6, we had libraries and packages. Then at 5, we saw scripting and automation followed by web development. Then we had machine learning and data science at number 3 and number 2 respectively. And finally at number 1, we had career opportunities and salary.
So who is a Python developer? Let's answer this. So here are some of the technologies used by a Python developer. Pandas, Anaconda, TensorFlow, Python IDEs, Django Web Framework, and Python. A Python developer is one who develops backend components of a web application using Python when working as a web developer. Now, the web frameworks like Django and Flask are used for this purpose. A Python developer is also the one who writes effective, testable, and scalable Python code. He also performs data analysis when working in the field of data science. So basically, a Python developer develops, deploys, debugs, and maintains a project. So let's go through the skill set of a Python developer. Now, the core Python skills that a Python developer possesses are data structures like arrays, list, stack, queues, trees, and graphs. There's OOP concepts like inheritance, classes and objects, and abstraction. There's packages and functions, that is importing external packages into a Python code. Database and its connection, that is connecting a Python backend to a database like MySQL. When it comes to data science skills, there's NumPy, that is a library for performing mathematical calculations. There's Pandas, that is the library for storing and manipulating data efficiently. There's SciPy, and then there's Matplotlib, which is a library for plotting charts and graphs for a given data. And finally, there are machine learning algorithms, which consist of models like supervised learning, unsupervised, etc. Now coming to web developer skills, there are frameworks like Django and Flask for backend development of web applications. And then there's web scraping, which includes taking data from websites and converting that data into usable format. There's API handling, which is basically handling API requests for a web application to perform server-side operations. And finally, there is backend connection, which basically involves the backend part of a web application, usually handled by Python frameworks. Now moving on, let's look at the Python developer job roles. First up is Python web developer. Now a Python web developer usually writes server-side code, works on the web frameworks like Django and Flask, collaborates with the data team to gather end users' requirements, develops the server-side platform, deploys applications, performs tuning, usability, improvement, and automation. Moving on, next job role is data analyst. Now a data analyst generally works on Python libraries including Matplotlib, NumPy, Pandas, etc., carry out data analysis, collect using the scripting language, explore data sets, gather requirements, tune in applications, analyze problems, communicate findings with the team or stakeholders. The next job role is automation test engineer. Now an automation test engineer usually works on Python test framework tools including PyTest, PyUnit, perform complex system tests, troubleshoot code issues, create test scripts, design the automation framework, perform A/B testing. Next up is machine learning engineer. Now a machine learning engineer has the following roles: to perform statistical analysis of data, put machine learning models into production, research and transform data science prototypes, research and implement appropriate ML algorithms and tools, perform ML tests, and keep updated with the ML trends. The last job role is software engineer. Now a software engineer is expected to write server-side code, collaborate with the design team to gather end users' requirements, develop the server-side platform, deploy applications, perform tuning, usability, improvement, and automation. Moving on to the next topic, let's look at the Python developer salary trends. Now, software engineers with Python skills are offered better salaries across the globe. The average salary of a Python developer in India is around 7,55,000 rupees per annum. The average salary of a Python developer in the US is about $79,000 per annum. Moving on to our last segment, Python developer resume. So let's go ahead and understand what a Python developer resume should portray. Just keep a few things in mind when you're preparing your resume. Your resume should be clear, updated, and concise. You should prioritize the skills according to the job role you're applying for. And do not write anything extra. That's a big no. The recruiters are smart enough to know that. So do not lie and do not write extra. Firstly, let's look at the fresher resume. So if you're a fresher, these are LinkedIn profile linked and also your GitHub repository link if you have. Next up is the projects. Now clearly depict the goal of your project. So just in case you worked on say 5 projects, make sure you keep it concise and crisp. Next up is your education. Do not lie here. Make sure you give relevant education with grades. Next you have the certifications. If you have any certifications or achievements, go ahead and write them down. Next you have the technical skills. Now again, prioritize according to the job role. And lastly, you have your non-technical skills. This could be your communication, analytical skills, problem-solving skills, etc. Moving on to an experienced developer. So again, mention the resume header. Then you have the summary, again very crisp and clear. Go ahead and mention your portfolios and your links. Coming to experience, now here you'll have to clearly depict your work. You'll have to make sure that you write down all your responsibilities in that company. Do not go overboard and write extra. Keep it very concise. Again, relevant education and your grades. You have technical skills. The same goes for this as well. Prioritize according to the job role. And finally, you have your non-technical skills.
Now let's go over some of the features of Python. And these features are actually why it's considered that using Python is advantageous over using other languages. So let's start with some of these points. Now, as we mentioned, Python is it's a very readable program. Code readability is very important. It's one of the design philosophies behind this when it was being developed. It's very easy to learn, which is why Python is an entry point for many people that are just beginning to learn programming. And as I mentioned earlier, it's a high-level language. In Python, since Python is open source, as I had already mentioned, so it benefits from all the benefits you get from any open source technology. Now, it's also portable. So what this means is that if we create a code in Python and we create it in a particular system, say on Windows, we don't need to make any changes if we wanted to use the same script or that same piece of code on some other system, say on a Linux system or a Mac system. Python itself comes with a very large standard library. This facilitates us a lot because we don't need to create our own libraries or modules or have to download very specific libraries. Most of the problems that we do encounter quite commonly can already be solved by the standard libraries that have already been provided by the developers of Python right from the beginning. Now later on during the course, we will encounter what is the meaning of a data structure. A data structure is essentially manipulation of an object of data. And as you will see later, Python has one of the most user-friendly data structures that can be found in any language, especially compared to some of its contemporaries. Now, Python is a dynamically programmed language, and this is very important. And what this means is that in most compiler-based languages, there are certain processes that can only happen during the compilation stage. So what a dynamic programming language does is it takes all those compilation-specific tasks and processes, and it does it for us as we actually type the code. So we don't need to waste time or spend extra time to do something that would otherwise be needed to be only done in compilation. We would have to set out specific runtime just for that. So this allows us to create our programs and solutions much faster and allows us to debug much easier. And so it's a very important feature about Python. Now, quickly, I will just go over some of the areas of Python where, like, areas of or different domains where Python is very heavily implemented. And the first few ones that come to mind are like web development and are AI and machine learning. So you have technologies like Django and Flask that are built on top of Python that are used extensively for web development. When it comes to something like artificial intelligence or machine learning, you have distributions such as Anaconda, you have Pandas, and many other libraries like SciPy and NumPy that are used extensively to tackle problems in this domain. And similarly, Python finds use in most of the scientific work that goes on nowadays because of, again, some of the libraries that I have already mentioned, such as SciPy. Interestingly, if you are into game development or gaming in general, you would see that Python actually has certain libraries and certain technologies that facilitate game development very, very well. One very popular game, in case you are into gaming, is a World of Tanks that is built on Python. Some of the other applications are, of course, creating desktop GUIs, image processing, graphic design applications, and something that is very relevant to me and, of course, you as well, is creation of education programs and training courses. There are many technologies in the environment of Python that were almost designed for the specific purpose of being able to present certain concepts or to be able to teach certain classes, and I can't think of too many programs or too many environments outside of Python that are better to solve these education and training course related problems and situations. Let's get to actually installing Python. So now that so I will show you how to install Python on Windows, since I have a Windows system. However, I will also point out the way you would have to install Python on Mac OS or Linux or even on mobile. So yeah, let's get started. So to install Python on your Windows computer, it's as simple as going to the website python.org and selecting the downloads section. When you do click on downloads, you get redirected to this website, that this web page that I'm on out here. It by default, it will ask you if you want to download Python 3.9, which is the latest version. But of course, if you, for whatever reason, if you needed a particular version of Python, you can download that as well by just scrolling down and choosing the option that you want. Now, it's important to note that whatever option you choose, of course, I would recommend the latest one, but no matter what option you choose, I would recommend you choose a version of Python 3 point something, because previous versions of Python, namely Python 2.7 and basically every version of Python 2 point something it will not receive any more maintenance and updates because the developers have decided that Python they are trying to shift towards maintaining and updating Python 3 point whatever completely right now. So yeah, let's not delay this any further, and let's just download Python 3.9. So once you select the option out here, you'll get an installer. All you have to do is click on that, and it'll give you two options: to customize installation or install now. I would of course recommend just to install now, since you're a beginner. Do not worry about what a custom installation is. If you have multiple drives in your system, by default the Python will be downloaded into the drive where your Windows is actually installed, your main drive. So as you can see, now that once my setup is done, it should give me a pop-up soon. So my setup is done for Python, and this is essentially how you would download Python on your Windows system. But what if you had Mac OS, or if you were using Linux? Well, for Mac, it's actually almost as simple. You just go, if you see out here below this download button, Python option, you get the website asking you, are you looking for Python on a different OS? And it gives you the options of Linux, Mac, and even other OSs. But for Mac, if you wanted, you would just open this tab, and just like the Windows option, you would choose a version and you would choose an installer for that version. So if I wanted, say, Python, the latest one, I would just download this installer and I would install it on my Mac system. Now, when it comes to Linux, I cannot show you exactly how you would install it. There are certain commands that you have to execute, but essentially, again, if you would just choose the Linux option out here, it would take you to a page with different installers and essentially packages for Linux systems in specific. What I would recommend to you, if you are a Linux user and you need Python, is to go over to the realpython.com website, and they have a very good essentially instructions on how to install Python. And since I don't have a Linux system, I cannot directly show you how to install Python on Linux. So yeah, if you do have Linux, please head over to this website, and this should be of a lot of help to you. Now, as I had mentioned, you can actually install Python on your mobile devices as well. So if you were, say, an iOS user, you would go to the iOS App Store and download an app called the Pythonista app for iOS. It essentially is like a full-fledged Python environment where you can develop in Python on your iPhone or even iPad. And if you were an Android user, you would go and download an app called the PyDroid 3. There's a free version and a paid version for this app. And of course, the difference between the free and paid is that the paid supports code analysis and code prediction. These are certain details you don't have to worry about right now. And honestly, if I wouldn't worry too much about installing Python on your mobile devices currently, since I am assuming most people would be learning programming in Python on their PCs or laptops. What I had actually shown you was installing what is called an implementation of Python on your system. An implementation is essentially a program or a software or an environment that allows you to actually work in Python. So what I showed you was how to install the by default or the most basic or reference implementation that has been created by the developers, which is actually called CPython. Even though you would not have seen the letter C or the prefix C, but yeah, that implementation that I had downloaded myself and I had shown you to download is actually the CPython implementation, which is Python built on top of C, the C language essentially. There are other implementations such as IronPython, which uses the .NET framework, and JPython that uses Java virtual machines that you could use if you were interested. But again, these are things that I would not worry about too much right now. So now that we have tackled on how to install your implementation of Python, I want to introduce what is called a distribution to you. This distribution is called Anaconda. Anaconda is a very important distribution, especially if you are looking to use Python in data science and machine learning and AI, which I am assuming is the motivation for many of the people that are actually watching this video, that they actually want to move into data science and they need to learn Python as a foundation towards moving towards data science. And if that is your goal, or in any case, whatever your goal may be, I would recommend that you install Anaconda distribution. Now, do not get confused between Anaconda and Python. Anaconda is Python with in the form of a bundle, and this bundle contains not only the basic Python implementation that I had shown you to download, but it contains a lot of extra libraries and technologies and softwares as well. So, of course, this means that would you need to download both? Of course not. If you downloaded Python, you do not need Anaconda to work on Python. And if you have already downloaded Anaconda, which I will show you how to do it in some time, if you have already downloaded Anaconda, you don't need to download Python separately. So I'll just speak about Anaconda a little briefly. So as I said, it's a distribution. It contains a bundle which includes the basic Python implementation and a lot of technologies and softwares and applications that essentially help us to use Python in specifically managing big data applications and data science related projects. So now I will show you actually how to install Anaconda on your system. It's as simple. It's actually as simple as downloading just this thing. So if I did a quick Google of Anaconda, so the website that I'm looking for is anaconda.com, and I'm looking at products and I'm looking at individual edition. There are other editions as well, like commercial, team edition. These are for companies usually, or for more professional sort of projects. So of course we are looking at the individual edition, and if you selected this page, you would be taken to this particular web page where it'll ask you if you want to download. And again, there are options depending on which machine you're using. If you're using a Linux, you would choose one of these two. If you are using Mac OS, you would use one of these two. And since I am a Windows user and I have a 64-bit system, this is the option I would use. So again, it will first download an installer for you. And as you can see, my installer has been downloaded. So upon opening it, it will open up this installation thing. You can just click next on most of these. Again, if you want to specify your destination folder, you can change it here. Mine will be with a default folder in the C drive, and you can leave this unticked. You can change these options much later. So this is how you install Anaconda on Windows, and it's pretty much the same on other systems as well. Now once it's done, I will show you what are some of the things that Anaconda contains that are not there if you installed Python, like the way I had shown you earlier, just the bare bones Python implementation. So as you can see here, my installation is actually complete, and now I will open Anaconda and I'll show you how you can actually use this Anaconda. So if I search for Anaconda in my system, I would look for something called Anaconda Navigator to actually get started with this. And when I open that, it should open something like this. So this is what opens when you click on the Anaconda Navigator. And as you can see, there are a bunch of applications. You don't need to worry about what these mean right now. Just understand that this is essentially a bundle of different applications and technologies that come along with just the normal installation of Python that you get when you install Anaconda Navigator. Now that we have actually tackled where we've seen how to install, and I'm hoping, and I would recommend definitely that everyone is watching this video installs Anaconda, not just the normal Python installation or implementation. Now that we have gotten all the introductions and the basics and the installations regarding Python aside, let's get down to actually creating our first script. So now the question is, how do we actually start doing this task of creating our first Python script? How do we realize now that we've installed Python, how do we start doing something? So the answer to that question is that typically when you're working on Python, one of the most basic things that you can do is create a Python script and execute a script. A script is essentially a sequence of commands and instructions that you give for Python to run and execute to give you a certain result. So I will show you how you can create a Python script. Now there are multiple ways of creating a Python script. You can create it directly from command line, which is obviously something I would not recommend because it is not convenient and easy, and it's not very useful for a beginner. Another way is using a text editor, such as the one I have opened right now, which is the Notepad++ text editor. Now it's very important to not get confused between Notepad++ and the standard Notepad that comes with your Windows or WordPad for that matter. In fact, text editors such as Notepad and WordPad that you are more familiar with create text and files in a form that is called rich text. Now, rich text is text that contains formatting and fonts, which is actually a hindrance when it comes to creating actual code. So what we need is a text editor that creates or writes text in what we call as plain text. Plain text is obviously text which does not contain these fonts and these formattings, and it only respects white spaces and indentations, those two being actually useful towards creating code, unlike fonts and formatting, which are only a visual thing. So Notepad++ is obviously a text editor that creates plain text documents. That was actually created with programming in mind. Obviously, you can use a bunch of other text editors such as Vim and Atom, and you can Google for these. There are plenty of them. So without any further ado, let's create our first Python script. So one of the most famous examples of a first program in any program for that matter, not just Python, is creating a print statement that gives us a statement saying hello world. So in Python, this is how you would go about it, or this is the syntax you would use to create this statement. Alright, now where it is very important when you are saving your Python program that you use the .py prefix. So if I were to save this, I can choose whatever folder. I am going to choose, this folder seems fine. So now I give the file name over here as, say, I want to keep it as test. I need to prefix this with .py, and this tells any sort of interpreter, or anytime we need to read the script to know that it's a Python script, we need to add a .py. Otherwise, it will not be treated as a Python script. It will be treated as some normal document sort of a thing. So now that I have stored it as .py, I have created my first Python script. Now, obviously, the next question is I need to see what happens when I execute this line, when I run this script, essentially. So to see that, there are multiple ways. The first way that I will show you is a command line method, which is obviously, again, before we get into it, it's not something that I will be using to teach you. It's not something I would recommend you to immediately start using. But for the sake of showing, I will show you how to execute a script in command line. Well, to do this, since I have installed Anaconda in my system and I will be using Anaconda to work in Python, what I will look for is something called the Anaconda prompt. As you can see, this is the option that I get, Anaconda prompt. This will essentially open you a command line under the environment of Anaconda or Python. So in this, now I am already in the folder, I believe, that had my script. So how do I call this script, or how do I run this script? Well, the command is Python space the name of my file, which was test. Of course, the prefix is very important, so I enter test.py. If this was in a different folder, you would have to change your folders in command line, which is again something that I might show you later. But since my file is already in the folder that I am in my command line, I would just have to enter this command right now. So if I execute this, as you can see, it's given me an output of hello world, which is what I wanted. I wanted it to print these two words. And of course, the command line is now waiting for the next command for me. So this is one of the most simple ways of, or the most rudimentary ways of executing a Python script. Now, another question would be, well, this isn't the most visually appealing or not the easy to read or easy to use way of executing scripts. And I would agree. And that's why I'm going to introduce another technology or a software called the IDE. So the IDE in Python or in any programming language stands for Integrated Development Environment. It's essentially a software that not only allows us to run scripts, but it allows us to create the scripts, it allows us to debug, it allows us to see outputs, it allows us to see intermediary outputs, it allows us to do a wide variety of tools and tasks, and it comes with a bunch of robust features to enhance our Python programming experience. So let's see. So I will show you an IDE called Spider, which comes bundled along with the Anaconda distribution that I had mentioned earlier. So if I open the Anaconda Navigator, as you can see, the Anaconda Navigator shows me a bunch of technologies and options, and I'm looking for something called the Spider IDE, which is over here. As you can see here, it's a scientific Python development environment. This is exactly what I'm looking for. So I am looking to launch this. So now that I've launched it, you can see out here, this is what an IDE looks like. Now this looks very sophisticated, and almost any IDE is a wonderful software where you can create your code, you can debug your code, you can check the results, you can make adjustments, changes, and you can do a wide variety of tasks and functions with relation to your programming. So this is the Spider IDE in particular, and this is how it looks. Don't worry about the exact details. Just know that on this left-hand pane is our current script that is open out here, and out here we will get the results in this is what we call a console essentially. So now that we have already created our script in Notepad++, and I want to open that script and I want to see the result of that script would look in an IDE. So let's just open it. So we can browse for our file, and as I had named it test, this is the file over here. I open this, and as you can see out here in the left hand pane, my script has opened, and the command that I had given or had written is out over here. Now if I want to run this application, I press this green button, and as you can see, the result of my execution essentially is over here. It's in slightly small font, but as you can see over here, it says hello world. And the next line is essentially it's waiting for me to do another execution of the script, and then it will give me new results. So let's actually give the system new results. So now that I have printed something called hello world, let's change what's written over here. Let's say I will perform basic maths. Alright, and let's actually perform the basic maths. Again, don't worry about the details, the syntax, what I'm exactly doing. These are things that we will actually cover in upcoming videos and modules. So let's create a variable called a. Let's store a number 3. Let's create a variable b, store a number 5. Alright, let's create another variable c, which will store the result of what's in a and b, in the addition of a and b. Alright, and let's print the result, or print what's in this variable c, or what's the result of a plus b. I will print a statement saying the result of the addition of 3 and 5 is, alright, and I will put my result over here. As you can see, I should get the result in this pane. So let's execute this, and you can see my first line is executed saying I will perform basic maths, and the next line says the result of the addition of 3 and 5 is 8. So in this script, what I've done is I performed 2 print statements, and I've performed a basic expression, some variable assignments. All of these things we will be doing later. This is what I'm essentially trying to show you is that IDEs are a very convenient way of not only creating the scripts but actually seeing the results and then making adjustments as well. We can create a completely new script. We don't need to create a script from some special file or text editor. I can just create a new file here, and this is my new script essentially. So I can start working with this new script right over here from the get-go. So IDEs are very powerful. Spider IDE comes bundled with Anaconda. There are other IDEs such as the IDLE IDE. It stands for indicated development and learning environment. So the IDLE, IDE comes as part of the basic Python implementation that I had shown you in the previous video, where if you just installed a basic Python implementation, it would come along with a basic IDE known as IDLE, or Integrated Development and Learning Environment. But of course, since we are using Python, and that is what I would recommend, it comes with a more robust IDE called Spider, which is actually very, very helpful for scientific and numeric applications, and was designed specifically with that in mind. Now, this is not the only way we can actually work with Python. There's another very interesting and a very educative method of creating Python, let's say Python programs. And it's something that I will be using extensively throughout this course to explain different concepts. So this technology is called, or this software is called notebooks. Now, before I get into the details, I will just open a basic notebook. So the notebook that comes as part of Anaconda is called the Jupyter notebook. And when I open, or when I launch the Jupyter notebook, this is what I get. Now, a very important feature, or a feature of notebooks, is that notebooks are a web browser or a web-based application. So it's not something that you can use if you are offline or disconnected. Basically, if you're disconnected from the internet, it is something for which you would need an active internet connection. However, it is way more robust, and it has very, very good properties that allow it to be used in education or for presentations and such. So as you can see, this is my Jupyter notebook. These are a bunch of folders. You don't need to worry about what these are right now. I will show you how to create a fresh notebook. So if you go here, you go to new, and you select under notebook the Python 3 option. It will open your first notebook. As you can see, this line is essentially waiting for me to enter some sort of a command or a statement that I would give in a normal Python thing. Now, if you would have noticed until now, everything that we were doing involved us creating a script, which was the whole series of commands and functions. So if I go back to my Spider IDE, as you can see, like, this is a whole script, and this script contains multiple different tasks and functions that are individually being performed. So this is a separate print function. This is a separate addition, another separate print function. And for longer programs or larger programs, you'll have multiple different tasks being done. And if you were using a script, you can only see the result of something like this by executing the whole thing at once. You cannot see exactly what is the result of just this print statement or just this. It's not typically what an IDE is used for. And this is where notebooks come in super handy. If I had to break down my previous script, essentially, where I first did a print statement, where I said some random thing, say hello. Yeah. So if I execute this particular line, you can see it gives me the result. Now I want to do what is 5 plus 3. It should give me the result over here, 8. Now the next, another part of your program might be storing 5 and 3 into variables. So I can do this, and I can do this. So now this line will store the variables. Now I want to do the addition of what is 5 plus 3, but I want to use the variables, and I want to see what's the result. As you can see, a plus b means 5 plus 3, which is 8. And I've essentially broken down various different parts of my previous script into its individual tasks, and I'm able to see what each part of that script does. And this is very good when it comes to making presentations or trying to teach a class. So I will personally be using notebooks a lot to explain different concepts of different concepts when it comes to Python. And I would recommend that you get used to notebooks in general, because it's an amazing way to learn Python programming, or programming in general, in fact. And again, as I had mentioned earlier, notebooks are something that it's an online application. It's a web-based application. So I will have to need a active internet connection to be able to work on a notebook, which could be a disadvantage if you do not have a consistent internet connection. And in that case, you would probably use your IDEs or text editors, which can be used offline as well. In this video, we will be introduced to the concept of variables and expressions. Let's start with expressions. Well, an expression in Python is anything that results in a value. Its difference, or the difference between an expression and a standard statement in Python, is that a statement in Python is something that results in an action or an execution of a command. There is no calculation per se, or any sort of manipulation, or, as I said earlier, calculation resulting in between two different, say, numbers or other objects that results in a value. And this happens in the case of an expression. So for example, if I were to add two numbers, say 5 plus 10, this is an expression where two objects, 5 and 10, are being added and a result is being given to me, which is 15. Now let's see an example of a statement. Well, a statement could be something like a print statement. So when I ask Python to print something for me, it's not calculating anything, it's not evaluating anything, it's simply performing an action that I have, or a command that I have given the system, which is to print whatever I have entered over here, as you can see. So this is a statement. Similarly, there are another type of statement known as assignment statements, which we will learn actually right in the next section. Well, let's move on to variables right now. Now, earlier, you might have learned about objects in Python. So objects are essentially data that we can work with or manipulate in Python. Now, variables are a place to store these different objects. Usually, it's much easier to store objects in Python instead of using the objects explicitly themselves, because objects may be very complicated, whereas variables are very simple to use and very simply are named in a very simple manner so that we can use them quite often in our programs. Now, it's important to note that in Python, we do not have to explicitly declare or define a variable to create them. In fact, variables are created in the same statement where we assign some object to that variable. In Python, the assignment of variables happens using the assignment operator, which is the equals to sign. So if I wanted to assign a number, say 100, to a variable, say b, well, it would be as simple as doing this. Now, anytime I want to know what is stored in b, I just have to enter b and I will get the value that is stored in it. And we can store different types of objects inside any variable. Let's say I want to store this particular word in the form of a string. Now this is stored in x, and if I want to know what is in x, I can just see what is here, and it's a string hello, which I had stored earlier. Now it's very important that we follow certain naming rules when it comes to naming our variables in Python, or else we may be thrown errors or we might get some problems in our program. So the first rule is that you cannot start your variable name with a number. So if I were to give a variable name like forNum is equal to something, say the same string hello, this would be an illegal variable name and I will get an error when I try this. So if I were to choose in num4 is equal to hello, this would be perfectly fine. I won't get an error. The second rule is we are not allowed to use any non-alphanumeric characters except the underscore character while naming our variable. So for example, if I were to name my variable num underscore 4 and I said random, some random string, this is perfectly fine. However, if I changed num underscore 4 to num hyphen 4, this will throw me an error, as you can see over here. Next, the third rule is that variable names are case sensitive. So if I have a variable called num, or say num, if this was one of my variables and I stored, say, the value 50, this is not the same as me writing num all in capitals and say storing some other value 60. These are two different variables. So it's very important that when you name your variables, you are aware of what case you are writing them in, because Python variables are case sensitive. Now the final and probably one of the most important rules in Python is that you're not allowed to use what we call reserve words.